Today we started working on some combinatorics, specifically permutations, ways of figuring out how many different, I don't want to say combinations because that's something different, but it's basically ways of counting possibilities. I'll give you an example. In number 11 it says 600 people are competing in a triathlon. There is a $1,000 prize for first and a $500 prize for second. How many different first, second place finishes are possible? So if you had, if the names of the people in the triathlon were, let's just give them letters, A, B, C, D, E, F, etc. Obviously we would need more than 26, there's 600 of them, but you could have finishes like this. A could finish first and B could finish second. B could finish first and C could finish second. You could also have B finish first and A finish second, and this would be different than this. It would be different in this case because there's a different prize for first place than there is for second place. So AB is a different finish than BA, and those are called permutations when the order matters. So we have 600 items, 600 people in this case, taken two at a time. So it's a permutation of 600 people taken two at a time, and the formula for permutations is, I really should give the general formula first, NPR, the permutation of n items taken r at a time, is equal to n factorial divided by the difference between n and r factorial. And we derived this formula by looking at some tree diagrams and some sample spaces today with some problems with smaller numbers. So substitute these numbers for n and r into this formula and then see if you can calculate the number of, or see if you can find how many different first and second place finishes are possible during the pause, and then come back and compare your work to mine.
Paused.
Okay, n is 600. So we have 600 factorial, and you should not try to calculate that. It's way too large a number. You can't even do that on a calculator, but we won't need to, and you'll see why. Then down here in the denominator we have 600 minus 2 factorial, which simplifies to 600 factorial over 598 factorial. So if you expand the factorials, we learned that n factorial equals n multiplied by n minus 1 multiplied by n minus 2, and you keep following that pattern until you get to 1, until you just subtract enough from n until you get down to 1, and you're multiplying all of these factors together. So if we expand 600 factorial, it would be 600 multiplied by 599 multiplied by 598, multiplied by 597, multiplied by ... Okay, it just keeps going on and on forever. And I mean, not forever, until we get to 1. But 598 will be 598, multiplied by 597, multiplied by etc. And so the 598s cancel, the 597s cancel, and everything else in this denominator will cancel. And they all represent one whole. 598, 598s, 597, 597s, all become 1, and what we're left with is this expression for the number of first and second place finishes, 600 multiplied by 599. You can use a calculator on this part. 359,400. which, if you look on the right side, that is one of the possible answers. And so underneath the number 11, you'll write the word married to finish off the riddle. Another way to think about this is how many people were available to win first place? 600 people. And then once someone has, let's say it's person R, once you determine your first place finishers, how many people are available to finish second place? Well, one less than the 600 because R has already won first place. So that would be 600 multiplied by 599. It's another sort of, it's wrapped up in that whole idea of the fundamental counting principle. How many choices do you have for first? How many choices do you have for second? Okay, I hope that helped with the homework. I'll see you tomorrow.